Hello and welcome to Building SaaS on AWS, the AWS SaaS Factory show for builders of SaaS here on Twitch. My name is Anthony McClure, and I am a solutions architect with the AWS SaaS Factory and your host for today's show. If you are currently a builder of software as a service solutions or are just beginning to learn about how to design, develop, deploy, and run a application in a multi-tenant environment, then this is the show for you. In every episode, we strive to bring in subject matter experts that can dive deep into the many varied topics of software as a service. And today is no exception to that, as I will have with me not one, but two folks from AWS that will be talking about the important concepts of building out a data architecture in multi-tenant environments. So that being said, let's go. We do. I want to say a quick thank you and hello to everybody that is joining us in the comments section today and live on Twitch. Be sure to give a shout out. Let us know where you're from while you're joining us. And be sure to say hello to our great moderator, Mr. Bill Tarr, who is once again in the chat answering questions for us today. If you do have any questions for myself or for my guests, please feel free to put those into the chat. Bill will either try to answer them straight away, or if it's something we should bring up to our guest, I will make sure and bring it up, and we will try to answer those questions as quickly and as soon as we possibly can. So, busy show today, so let's go ahead and get right on into it. I want to introduce first our first guest today, Mr. Josh Hart. Welcome to the show, Josh.
Thanks, Anthony. Great to be here.
Awesome. And Josh, why don't you tell us real quickly a little bit about yourself, what you do here at AWS?
Yeah, absolutely. So I'm a solution architect at AWS. I'm in a team called the ISV team. If you're not familiar with the acronym, ISV means independent software vendors. So that means I work with enterprise software and SaaS companies to help them get the most out of AWS. I've been here about 3.5 years, and before that, I was a happy AWS customer for about 5 years. So I've been in or around AWS for a good while now.
Awesome. Well, thank you very much, Josh. Looking forward to speaking with you. But let's add in our second guest as well as I bring Mr. Dave Roberts to the show. Dave is a fellow colleague of mine from the SaaS Factory. Dave, want to introduce yourself?
Thanks, Anthony. Hi, I'm Dave Roberts. As Anthony mentioned, I'm also on the AWS SaaS Factory team. So I get to go out and help our customers, our partners on their SaaS journey. But I'm based in EMEA as opposed to Anthony's in North America. Been with AWS for 4.5 years and solely on the SaaS side for about 2 years. And yeah, I love talking SaaS.
Really great. And yeah, so Dave is with me here on the SaaS Factory. Dave, can you give us a quick overview for those that may be new to the SaaS Factory, who we are and what we do?
Yeah, exactly. So when you're building a SaaS product, wherever you are in your SaaS journey, it can be quite a challenge, especially if it's when you're coming from a background that isn't SaaS. It's a whole new domain that you may not have expertise in. So we go out and we help customers on a number of different engagement levels. We can come in and give sort of instant advice or workshops, or get engaged with your teams on a longer term engagement where we drive a new product to release. And that can be anything from going from on-premise into the cloud as a first start of your SaaS journey, or maturing your product where you're looking at increased profitability or scaling out into new regions.
Awesome. Thank you for that overview, Dave. And Josh, just based on the accent, I have to think you are also in Europe. Is that correct?
Yep, that's a fair assumption. I'm in the UK, near London.
Awesome. Very cool. As you can see, folks, we do have a truly global team here at AWS. We want to make sure that we assist our customers no matter where they happen to be. So definitely reach out if you have any questions for us. We obviously want to help you, especially if it has to do with anything related to SaaS for Dave and I. But getting into the topic of the day, we are going to be discussing modern data architectures built around and for multi-tenant SaaS. So before we kind of dive into this in depth, I'm really curious, Josh, how did you kind of get started thinking about this as a particular topic that you wanted to dive into? What's the driver behind this?
Yeah, it's a huge topic. Data is very much the kind of golden goose for a lot of businesses. It's really where a lot of the business value is, a lot of what they're able to derive in terms of insights and capabilities for end customers is locked away in that data. And very often it is locked away in a relational database that might be the single kind of monolithic relational database that we all know and love that services the entire application. Um, and that's not always the best approach. And one of the things that I most commonly speak with folks building SaaS about is how do we start to unlock the real value from that data? How do we really scale beyond what our monolithic database is capable of doing? And so that's why I started thinking about how can we approach a data-centric architecture, particularly for multi-tenancy, because multi-tenancy has, as you know, it's got its own kind of nuance and its own additional considerations when we're thinking about all aspects of application development, but specifically on the data side.
Very interesting. And how about you, Dave? Did you get roped into this one way or another? How did this come for
Yeah,
topic for
well,
you?
historically, I had some background in storage, so I was a NetApp architect back in the day. But it's always really interested me, because if you look at SaaS, one of the core foundations is around protecting what belongs to the tenant, and
Right.
what you're protecting is data. So the topic of data and how you manage that inside your SaaS application is really interesting, and one of the cornerstones of architecture design. So I really gravitated towards it. And the more I learn, the more I discover I don't know, and the more I want to know. So yeah, here we are.
Yeah. Yeah. Of course, tenant isolation, data isolation being two very important topics in SaaS development, something that we talk about all the time as far as SaaS best practices, and data being really the linchpin to all of that, right? Protecting data, keeping tenants isolated. So that being said, if we're talking about data in a SaaS multi-tenant application, what are some of the key components or areas that we should consider when designing a data architecture with SaaS in mind?
Yeah, so building on what we were just talking about, it's very common, and most folks will start out with a single relational database. It's a super quick way to get started. Everybody knows a little bit of SQL. If not, it's very beginner friendly. And so, most applications, when they start out, they're going to be using that relational database while you kind of prove the concept, while you scale and establish yourself as a business. And that's totally fine. Agility early on is super important. But you need to keep one eye on the road and one eye on how that database is going to scale as your application scales. And at that point, think about what are the data access patterns, what are the data attributes and data characteristics, and then align what is the right database technology or data storage service for those particular characteristics. So you have to kind of acknowledge that at some point you're going to scale beyond the capabilities of trying to cram everything into one relational database. And those kind of Swiss Army knife relational databases, and you're going to begin looking at what is the right tool, the right purpose-built database to be able to fulfill these business and customer requirements.
I see. And so are you seeing that quite often then when customers are coming to you, especially in the ISV space, that when they're doing a modernization process, that really taking a holistic look at their data structures and where their data exists today versus forward looking into the future? Is it becoming very commonplace to include a data migration as part of those migration patterns?
Yes, yeah, absolutely. And I'd say we try to approach it as an overall data strategy. So it's something that is a conscious effort to move towards a defined end goal, rather than trying to align necessarily a particular database service in a particular area, but thinking about what is the overall data strategy and how do we get from where we are now, which is often that relational database, to where we want to be iteratively and in as smooth a journey as possible.
And one thing to be aware is this is where working backwards from the business use case is so critical. So what are your requirements? From the tenant isolation perspective, what are your customer requirements? That can have a big influence on what your options are from an architectural perspective.
Absolutely. So that being said then, and thinking about what this looks like from an AWS specific perspective, right? What are some of the data services that we should consider in order to fill these varied requirements that ultimately our customers are coming to us with?
And I think AWS has a purpose-built database strategy. So we don't try and prescribe one database that covers a whole range of different data domains. Rather, we provide a range of different databases that you can implement, that you can pick up and mix and match across your data architecture to fulfill all of those requirements. So really, it's about being aware of that data portfolio, understanding what are the capabilities of these services and what use cases do they align to. So to give a couple of specific examples, for highly transactional data, very high throughput reads and writes, DynamoDB is our managed NoSQL database that provides very, very low latency, very high throughput for those kind of transactional, online transactional processing, OLTP type workloads, where you've got lots, high concurrency of very small items being written, where persisting that data is the priority. But then on the other side of that, when we think about analytical workloads, kind of OLAP workloads, then perhaps we'd look at something like a Redshift, which is our managed data warehouse service, which is a columnar database that is very well suited to analytical queries, things where you're doing aggregates over large amounts of data, as opposed to individual reads and writes that you might be doing on the transactional side.
I see. And as far as multi-tenancy is concerned with these different services, do the services have some built-in capability in dealing with multi-tenancy, especially let's say in a pooled multi-tenant environment versus a siloed one?
Yeah, and I think this kind of back to Dave's point there around when we're considering that tenant partitioning model and that tenant isolation model, one of the considerations there is what isolation controls does my given database technology support, and am I able to meet those business and customer requirements using this database technology? The ones that I mentioned there's various ways that you can implement a pooled partitioning strategy. Very often that's a single table, and then we're doing something like row-level security to isolate our tenants' data. And then on the other end, you've got your silo isolation, and that might be, in DynamoDB's sense, you can have a table per tenant, and that's a very scalable model. You can have thousands of tables per AWS account, so having a table per tenant is a very, very scalable model. Or on the Redshift side, or on the relational database side, you might have a logical database per tenant, or you might have a database cluster per tenant, and there's different kind of gradients that you can implement depending on what those isolation controls are that you need.
And Dave, I think at SaaS Factory, we have quite a few blogs actually written about that very subject, right, of how to isolate data in various different databases and data stores.
Exactly. I think all the examples that Josh was giving in terms of technologies and services, we have models for all of those. And part of the real challenge is looking at the trade-offs as well, because if you look at tenant isolation, for example, there's always a trade-off, a cost to doing isolation. And it might be that the cost in a certain deployment model, say pool, or is too expensive for your use case. Maybe your performance has to be number one. And so that really pushes you down into doing a silo-based deployment. And we have the documentation, the guidance to help you make these decisions. And there are also resources within AWS that can come out and help your teams discuss these as well.
So Dave brought up, kind of the scaling factor again, and I know, Josh, that's really what you've been kind of hammering here too, which is, of course, very important in a SaaS environment. SaaS being a very big driver towards towards growth, right? That's we always talk about when we're talking about the value proposition of SaaS is growing your business. Well, that then comes along with scalability as well. You have to be able to handle that traffic and those loads. So how can we go about ensuring then that the data architecture that we choose will scale in response to this changing tenant activity?
Yeah, and again, that when we think about the database technology alignment, our different database services have different characteristics there. So on the DynamoDB side, DynamoDB, you pay per request. There's no fixed compute. There's no instances that you provision. So DynamoDB is able to very quickly scale in response to changing tenant activity, and then you just get billed based on that consumption that you're making. And if that usage ramps back down again, you'll just be billed on that lower usage. So those kind of serverless database technologies are great for where you have that variance in tenant activity. If we take a more kind of traditional database technology, something like a relational database, this is where AWS managed relational database services can add some additional capabilities over managing these relational databases yourself. So, for example, Amazon Aurora, which is our fully managed cloud-based relational database supporting open source database engines like MySQL and Postgres, has a couple of capabilities that are really important when we think about both vertical and horizontal scaling of that relational database that you wouldn't necessarily be able to do if you were managing those databases yourself. So with Aurora, one really popular capability is Aurora Serverless. And Aurora Serverless provides a way to vertically auto-scale your database in response to changing activity. So really powerful for multi-tenant scenarios where you've got growing numbers of tenants as you're onboarding new tenants, where you've got variable degrees of tenant activity. You can have the relational database scale vertically in response to that changing tenant activity, and then importantly scale back down as well if that drops back off. And horizontally, we can scale via read replica auto scaling. So with Aurora, you can have up to 15 read replicas in your cluster, and you can have those read replicas auto scale out in response to increased read activity. So those managed capabilities provide reduced operational overhead as you're scaling your SaaS application.
Let's see. And so do we see customers then kind of adopting the AWS philosophy, especially if they're in a modernization or movement to SaaS, moving their applications to SaaS, let's say. So following the philosophy of using built databases and really focusing the data in the correct location to get the best performance, the best scalability. Are we seeing customers adopt that?
I think, a lot of customers are on the journey. I think a lot of customers, it's where they'd like to be. Like I said, a lot of folks start from that relational database and they're breaking that apart. They're moving the access patterns out to these purpose-built databases. And some of the real success stories that we look at, some of the kind of flagship built on AWS SaaS platforms are well along this journey and are using a variety of these different database technologies, but also kind of fully going all in as well, not just using the technology at a wire protocol level, but also using those managed service features that I mentioned there in order to reduce the amount of operational toil that they have to deal with.
Mm-hmm. Yeah.
And I think an interesting point there is you kept using that word journey, and your data architecture is a journey. And you use that example of you start off and you have a single relational database. And you might have a serverless Aurora for that because you don't know what your workload's like. But as you grow larger, perhaps that database becomes a bit more consistent because you've got a large number of customers and your team's got experience with it, and you move over to a more cost-effective solution that isn't got so much management in there. And you carve parts out and put them onto Dynamo or Redshift and things like that. And that really evolves as your SaaS product matures as well. So you need to keep that. It's not I set this in stone at the start and that's my architecture forever.
Right. No such thing as a two-way door, right? or a one-way door, I should say. Yeah. Everything is a two-way door in this case. Yeah. So you did mention also preventing database bottlenecks, kind of really looking at these limits that can ultimately happen. So what are some of the common scaling limits that you seem to encounter with customers?
And this is a good one. There's two main areas, I think, where you're going to first run into an area where that relational database can be the bottleneck. The first of those, and I'd say this is by far and away the biggest performance challenge that you'll butt up against as you scale your relational database, is your connection management. So the connections from your application to the database. Each one of those connections that you establish has an overhead. It's a TCP connection, there's a TCP handshake, and then there is some resource utilization on the database to maintain that connection. So as you're scaling up and up and up, and you're having more and more concurrency, you're having more and more connections, you're utilizing more and more resources on the database, and eventually you'll get to a point where you are starving the database of resources just because of the sheer number of connections that you're having to maintain. And so that's where we start to look at techniques like connection pooling, connection reuse, and how can we reduce the amount of active connections that we're needing to maintain to the database, but still support the level of concurrency that we need.
Yeah. So I think maybe at this time it's probably a good opportunity for us to take a look at some architecture here, and how do we actually scale beyond those limits, right?
Absolutely, yeah.
All right.
So I think this is a fairly common architecture with a relational database as the data persistence component for this given service, given set of microservices. And what we've got over here, we've got the application. Within the application, we need to maintain the client libraries, so the drivers, JDBC drivers that we're going to use to connect to the database. So we've got a database access layer there, and we've got some management there on managing those external dependencies, those third-party dependencies. We've then got a client connection pool. So the client connection pool is optimizing the application being able to just retrieve an existing connection from a pre-existing pool of connections rather than having to create a new connection for every single database request. But then what we've also got here is this centralized connection pool. And this centralized connection pool is really important when we talk about scaling in the cloud, because we're probably not just going to have one of these. We're going to be horizontally scaling in the same way that we want to be scaling our database technology to meet changing variable tenant activity. We want to be scaling the compute as well. We want to be using auto scaling groups. We want to be making sure that we're procuring compute capacity on demand. But every time we do that, every step that we increase that by, we're having a new client connection pool or a new set of client connections that are being initiated. So if we have a sudden burst of activity on the front end and we're scaling out our compute fleet in order to be able to serve those requests, we don't want to then suddenly be opening a connection storm against the database, opening thousands of parallel connections in order to deal with that spike in activity. And that's what this component isolates you against. This component is a centralized connection pool that all the applications connect to, and then it maintains a set number of connections to the database.
Yep. So that's smart then. Yeah, actually have been in that very situation in my past where we were dealing with scaling up the compute dynamically and not necessarily thinking about the way that we should about the effect that would have on the database. So yeah, it's a bit of a scramble at that point, especially if you're maintaining connections at the compute layer. So extracting that out into its own service that the application layer talks to makes a lot of sense in this.
Yeah, and I completely agree. You're not alone there. I've done it. I learned this from going through that pain myself, and I speak to a lot of customers. It's far and away one of the most common scaling issues we see. But there's a lot of management going on here, right? You're needing to manage that driver layer, the data access layer. You're needing to manage that client connection pool and configuration, tweak that as that kind of tenant profile changes, and you're also needing to manage this as well. This is something that you have to provision some instances, a fixed number of instances or an auto-scaling group of instances in order to host that connection pooling capability. So, there is some operational overhead still in doing this approach.
Yeah, it's very fiddly, right? There are a lot of dials to tweak and valves to set, so to speak, in order to get this to work seamlessly.
There is, there's a lot of nuance to it, and it's it's not a set it forget it type thing. It's something you need to constantly be monitoring over time as that kind of tenant activity ramps up. And so something that we've released relatively recently that I'm really excited about is the RDS data API. And the RDS data API alleviates a lot of that operational complexity by removing the need to maintain any client drivers or any connection pools. So it really simplifies your client logic. It abstracts away all of the connection pooling so that you just have to manage sending a request to an AWS SDK in the same way as if you were talking to S3 or DynamoDB or any of those other services where the data plane exists as an AWS SDK call. You can now do that with your relational database on Aurora, which is really exciting.
Nice. Yeah, that is very exciting. Extracting away all of that undifferentiated heavy lifting that we like to talk a lot about when it comes to the cloud, right? Moving that off to an external, service that users can then just talk to via API really takes a big chunk out of the administration of these data planes away.
Yeah, 100%. Yeah, it makes the application side easier because you don't need to maintain that data access layer, and it makes the infrastructure easier as well because you've got those fewer components that you need to manage.
So for those of you that are just joining us, this is Building SaaS on AWS, the AWS SaaS Factory show for builders of SaaS here on Twitch. I am joined here today by Josh Hart and also Dave Roberts, both co-workers of mine here at AWS. And we are discussing building out modern data architectures in a SaaS multi-tenant environment. So, Josh, all of this being said, I think this is fantastic. This new tech that we have available here. You have maybe something to show us as far as what this looks like, how this actually gets implemented?
Yeah, absolutely. I'd love to. So, as I mentioned, this data API is a feature that's available for Amazon Aurora. So, it's available for both Amazon Aurora provisioned instances, but also for serverless V2 instances as well. Okay. So, if I flip over here to the AWS console. So I'm in the RDS console here, and here's what I made earlier. I've got a Aurora database cluster, and there's nothing special that you need to do in order to prepare your database to use the data API. All you need to do is be on a version of Postgres that is supported by the data API, and then just tick the box to enable the data API. And then what you get, in addition to your traditional endpoints, so you can use it side by side. It's not mutually exclusive, which is great. In addition
you could still create your own connections to the database. It doesn't limit you in that way.
Exactly. Yeah. And most folks will probably use a mixture of both. Right. But then you also get this indication here that the data API is enabled. And then once that's enabled, what I can do is I can then send my AWS SDK calls against the data API endpoint, and the data API is going to execute them against my database for me. Nice. So we can take a look at that from a couple of different angles. So one is this query editor. So the query editor built into the AWS console. So this provides a way of connecting to your database for those kind of ad hoc admin things where you just want to quickly look up some metadata or check some little bit of reference data. Usually you'd have like PG admin maybe installed onto a jump box, or you'd have to use a VPN to connect. But here you can just quickly go into the query editor, and I can run my queries within the console, get my results back, and I can do some nice stuff like save them here. So, it's a nice simple editor for those kind of ad hoc administration tasks.
One quick question. That's probably something that our audience is thinking about right now, and that is, since this is a service that exists between your application and the database itself, Is there much overhead that these calls kind of add, or latency that gets injected into the process?
Yeah, so you have to think a little bit about how you are managing the AWS SDK. So it's always a good practice to initiate the client of the SDK as a singleton and reuse it across different implementations and across multiple calls across the application lifetime. So you don't instantiate a client on each request, so that you don't have to go through the overhead of setting up the TCP connection to the data API service each time.
Right.
And that reduces a little bit of that TCP handshake on that side. And then on the other side, the data API is still maintaining its own connection pooling logic. It's just all abstracted away and managed as part of the service. So you can measure it yourself, and we definitely encourage customers to test it out, load test it in your environment to make sure it's suitable. But we've tested it up to kind of hundreds of requests per second without any noticeable degradation in performance. And an interesting thing about the data API is that there is actually no request per limit on the API. So the bottleneck that you'll likely run into will be the resource utilization of the queries on the database rather than the data API request limit.
Oh, that's excellent. Yeah.
So the other thing I wanted to show is just a bit of, show me the code. So this hopefully shows how simple it is to communicate with a database using the data API. This is all the code that you need. So all I'm doing here is using the Python AWS SDK, Bodo free, and I'm just initializing my client. So like I say, best practice, you would do this as a singleton somewhere, and you'd inject this into your class and reuse it across the application. And then here I'm passing the SQL statement that I want to run to this execute statement API call. So I'm calling the data API execute statement API, and then that is going to use its built-in connection pooling, its built-in logic to run the SQL statement against the database. So I've got no database drivers, I've got no connection pooling logic that I've had to set up here. So that's really nice for things like Lambda functions, where you want them to be as small as possible. You don't want to be bringing in a lot of additional layers for your data access layer. So those kind of serverless compute environments. And then I can just run it from the command line. Oops. Obviously, the demo got
timeout on the the authentication. Yeah, been there too. Authentication doesn't give you a fit here.
There we go. Okay, so now, sorry about that.
There we go.
So now I
no
can.
Worries.
So now I can run it back, and I get back the same response. It's a little hard to read it because I've just got the JSON back. I'm not formatting the JSON,
Sure.
But this is the exact same response from the information schema that I'm getting back in the query editor there. So as a slightly more interesting example, we can take a look at, how do we do this in a multi-tenant scenario for a SaaS? So, one of the things that Dave mentioned was around row-level security and maintaining tenant isolation, and that is, absolute, critical that we make sure that we don't expose one tenant's data across that tenant boundary. And so, using row-level security policies on the relational database are a really good extra layer of defense against misconfiguration to make sure that we're only getting back that tenant's data. And you can do that with the data API as well. So we can use row-level security to enforce our security policies on the relational database when we're using the data API. So the thing that's different here between the previous call is we're using this explicit transaction. So as well as the execute statement call that I showed previously, we're wrapping the whole thing in this explicit transaction. And what this does is it forces the data API to run all of the subsequent statements on the same backend connection. So the session state is preserved across a given transaction. So that means that we can do things like set session variables, which means that we can use row-level security policies. So here, I'm setting my tenant ID to something I'm getting from the context, Here it's hard coded, but you imagine you would pull this from the JWT token from a claim on the JWT. You'd get your tenant ID. We pop that in there, and then we're using that to set the tenant ID. And then we run here our next statement against the table that has our row level security policy on. So this has a policy on it that's going to say, that the tenant ID is going to filter that table automatically for us based on that session variable. Best practice, in your application, you should still have the where clause on here, and you should still explicitly do that. But developer mistakes happen, misconfiguration. We can see here, if we don't have that explicit where clause, what's going to happen is we're still going to only get back the data for that tenant that matches this tenant ID. So we can run this one. And we can see back, we're only getting back the data for tenant 2. And if I change that just to show, nothing up my sleeve, no smoke and mirrors, we can then see that we're only going to get back the data for tenant 3.
Fantastic.
Because it's maintaining this state across those individual statements because of this explicit transaction that we've got here. So, quite a simple way to implement a very robust row-level security using the data API. And one final point I'd like to mention on that before we go back is I'm running all this from my local machine. So this is just on my development environment in my IDE, and I'm running it against my Aurora database in the VPC. And I've not got a VPN. I've not got any connectivity set up. I'm not remoted onto a jump box in the same VPC, anything like that. Because all I need is, as you saw at the start when it went wrong, is an authenticated session, IAM credentials to use that allow me to make this execute statement SDK call. And once I make that authenticated statement, that goes to the RDS data API endpoint, which is then the thing that communicates with the database. So I don't need to have that direct network connectivity, which is really powerful for developers.
Yeah, that's great. So from your application in that case, then as long as the application has an appropriate IAM policy associated with it that gives it access to the RDS data API, with that information passed along, it essentially proxies the connection to the database for you, right? And it's just a lot less overhead that you have to think about when implementing your code. And it also is abstracting a lot of that security away from, maybe your mainline developers, which is another layer of abstraction security that you have using this technology.
And you said the magic word there, abstraction. So even though there's not much code here, if you're in charge of the control plane, you may provide a wrapper function, a helper function that simplifies this. So as a developer, you just say, hey, select statement and JWT, and this will do it all behind. So you strengthen things even further.
Yeah, this is fantastic. Yeah, it's great to see. So much simplifies the entire process of working with a relational database.
Yep. Yeah, absolutely. And like I said, I've shown the example from local compute environment, but also this could be a Lambda function, right? And we haven't got to think about how that Lambda function is going to connect to the database. That could be across accounts. It could be cross region. All of that connectivity complexity is something that we just don't have to think about.
Nice. No, this is excellent. Thank you. So beyond this, or kind of moving away from these technical areas of actually connecting to and working with the database in a multi-tenant way, we of course are always thinking about security here, and we've mentioned it multiple times up to this point. But are there particular considerations that we should think about when handling customer data isolation and security?
Yeah, so I think we touched on some of these a little bit already, but one of the main ones is making sure that we are aligning our isolation strategy, our data isolation strategy, to the business requirements, and doing that on a service by service basis as well. So if we've got, say if this is our sales service, it's processing sales data, maybe it's got payment information in there or customer identifiable information. We want to maintain a strong degree of isolation in that service, so we might have extra controls. We might take the overhead of having this explicit row level security defined for our transaction service, for our sales service, because of the criticality of the data there. But for something less sensitive, maybe we've got a product metadata service or something that has less business impact. If that data was to be accidentally disclosed, then we might choose to have a more relaxed approach to isolation, and we might not implement all of the same controls, because it is a trade-off. You're trading off the kind of operational efficiency, the agility, and even some cases the raw performance for those extra security guardrails.
And it's also essential that when you implement an isolation mechanism, that you also implement a testing mechanism for that isolation into your deployment pipeline. So when you roll out new changes, it's doing some testing of your isolation, so you're not getting any surprises because someone's changed some code somewhere along the line.
Yeah, injecting that little bit of chaos into your deployment pipeline can actually be a really valuable thing. We actually had to talk about this specifically at reInvent this year, how to go about and really think about, okay, we talk about doing tenant isolation, we talk about data isolation, we talk about all of these security layers we want to build into our SaaS applications, but are we actually testing that? It is a great question. It's right to what you're saying there, Dave. So 100% behind that. Yeah, actually test these implementations to make sure that what you're expecting to happen is actually what's happening. It's very important. That, I think, also brings us into another area of SaaS, which is metrics and monitoring and observing what's going on with our SaaS solution, right? So when we have these abstractions like the SaaS Data API and others here, which are great technologies, but we still need to be able to monitor the scalability and performance of these services as well. So are there tools to help us do that as well, Josh?
Yeah, absolutely. So the more distributed our architecture is, the more we need to have a comprehensive observability story, because the harder it is to just look at the kind of single moving piece and identify where the problem is. If we're using 3 or 4 different data services across our application, problems could manifest downstream when the root cause is something further upstream. So having that kind of end-to-end tracing and observability story woven throughout our application is really important. There is some stuff that AWS adds that can make it a little bit easier. So one that I think is really powerful is for DynamoDB, which is Contributor Insights. So Contributor Insights will show you down to an individual key level which items within your DynamoDB table are being most requested, and will then visualize that in a CloudWatch dashboard for you. So if you're using a row-level security where you have the tenant ID as part of the partition key of your DynamoDB table, you can use Contributor Insights to understand your tenant access patterns, understand where your hot tenants are, and think about, do we need to break these tenants out into their own table? Do we need to look at sharding and splitting these tenants down into individual sub-partitions? But you have the tools and the information there to make an informed decision about that.
Changing maybe gears just a little bit here, but still in this concept of tenant isolation and security. It's becoming very commonplace these days that you may need to move tenants, right? Or we may need to move from one database system to another database system, or from one tier, let's say, of your SaaS application to another tier of your SaaS application that may have different infrastructure. So when we're talking about tenant portability, what are some of the things that you see there, Josh? And are there ways that we can work through this?
Yes, it's a really good question, and it actually ties in a little bit to what I haven't mentioned yet, which was the second performance issue that I see a lot, which is that you have a single writer in your relational database. So if we kind of go back to thinking about what are those bottlenecks that you're going to hit with your relational database, whether you're self-managing that or whether you're using something like Amazon Aurora, you've got a single writer instance in that cluster. You can vertically scale that writer instance. You can horizontally scale the number of read replicas, but you haven't got anywhere you can go once you begin to hit the capacity of that single writer endpoint. So what people will often be drawn to then is application sharding. And application sharding, one of the kind of control plane components that you need in place in order to do that effectively is, as you say, about tenant portability and how do we move tenants around between shards? How do we rebalance shards when we have hot and cold shards? And that requires that being a conscious thought to build that into your SaaS control plane, that you're able to extract a tenant's data and move it to a new shard by one mechanism or another. But that again, setting up that application sharding, setting up that kind of control plane components to manage, rebalancing shards, to manage when do I need a new shard, when do I need to consolidate shards, and also in the application as well, making the application be sharding aware and know I need to talk to this shard for this tenant, or I need to talk to this shard for that tenant. Again, they're things that you need to manage and add operational overhead, and something you need to keep a close eye on as you scale. So that segues into another new feature that I'd like to talk about with Aurora, which is Aurora Limitless Database. And what Aurora Limitless Database does is it adds a serverless component to your Aurora cluster that will horizontally scale across a fleet of instances based on the shard key, which in our case, in our multi-tenant application, will probably be the tenant ID.
Tenant ID, sure.
Exactly. And will let us horizontally scale across a fleet of writers. And one of the most exciting things about that is it presents back as a single endpoint. So there's a fleet of routers that are aware of which shards contain which tenant's data, and they manage the query routing. That again, coming back to our topic of abstraction, is abstracted behind a single endpoint that our application connects to. So our application doesn't even need to be sharding aware. So it doesn't need to have any of that routing component or any of that understanding of where to send each query. We can just use the limitless database capability to horizontally scale our database across a fleet of serverless instances.
That's fantastic. So with that, then, with all that capability in mind, I should say, the same sort of structure comes into play as well. We've talked about, moving tenants or tenant portability in this case, but the opposite coin to that, I guess, is also offboarding of tenants, right? I mean, nobody likes to lose a customer, but we know it does happen. And we do live in a world of right to be forgotten, right? So, what do we need to think about when tenants leave our products as it relates to data?
Yeah, it's an important topic. And again, I think it comes back to, building it as part of your SaaS control plane from the start. So building the capability to offboard a tenant in a way that meets your specific compliance and regulatory requirements. So, for example, it might be acceptable that you can have an out-of-band background process that can just iterate through and delete the data incrementally, and it can just run in the background until the data is removed. You might have something that just substitutes the PII data, the identifiable data, for just dummy values. And then you can retain the data that perhaps has value to you, but without it being identifiable back to your end entity. Or you might go for the nuclear option, and you might just drop the database or drop the partition, or delete the cluster, whatever it is that contains the end customer's data. But again, it comes back to how you set that up in your control plane and what those business requirements and business drivers are that dictate how and when you delete that data.
I assume also the concept of backups, right, and archives is very tricky when it comes to this as well.
Yeah, and I think this is really where it comes down to your business case. So what are you going to do when a customer leaves? And if you've got a hard case to wipe all their data, then maybe you have to think about backing up tenants individually, which introduces more overhead into your backup procedures. Yeah.
Dave, are you seeing seeing this, especially with GDPR and right to be forgotten in Europe being the standard there? Are you really seeing our customers coming to us with concerns about this and how to implement, especially in the SaaS scenario?
Honestly, no, and I think this is more a general problem that we're seeing across a lot of customers. It's just that GDPR, even though it's quite old, is still relatively new in the amount of people that are asking to be removed. So it's not so common. But I've had a few discussions, but it's not something that's there as a design decision point, which it should be.
Absolutely. I think that's one of those conversations that many times we bring up, right? Actually, as we're discussing with customers, hey, have you thought about X? Have you thought about Y? Certainly right to be forgotten, GDPR, other compliance standards that the customers should be.
It's just cost as well, right?
Well,
a customer
that
leaves
well.
and you're paying for their data.
You're paying for data. Yeah, good point. Absolutely. Well, gentlemen, we're actually coming up here close to the close of our show together. It's been incredibly informative. But before we leave out here today, Josh and Dave, I want to give you an opportunity. You have any last thoughts that you'd like to pass on to the audience before we close down? Josh, we'll let you start.
Yeah, absolutely. Well, yeah, thank you. I think the kind of key message I want to reiterate is, choose the right database technology for the right job. Too many times I hear people say, "Oh, we're a MySQL shop, we're a SQL Server shop," and that'll get you so far. But then when you get to that kind of scaling point where you want to start thinking about global presence and where you want to start optimizing that scaling as well. So not only being able to scale, but do it in a cost-efficient way where your cost per tenant is either static or decreases, so you get some economies of scale from your growth rather than it increases or exponentially increases. Then you want to align the right database technology and use all of that database technology's capabilities. The cloud provides fantastic operational efficiencies if you lean in and use these database services to their fullest. If you're just dipping your toes in, you won't get a lot of that benefit. So really consider what is the right database technology for my data characteristics, data access patterns, and do that on a service by service basis as well. So find what your bounded contexts are, find what the right database services are for those bounded contexts, and then implement them in isolation without having to try and be a single bottleneck or a single one size fits all solution.
Yeah, and I'd also say, as you're choosing those solutions, try and come up with singular architectures where you can across partitioning models. So even if you have silo and pool, and silo doesn't need a runtime isolation mechanism, having them both using that same mechanism for isolation or for metrics is going to really help things like your control planes, because you end up having a singular process to monitor, to make changes, to do migrations. Tenant portability becomes a lot easier. So that can be a real advantage if you've got larger environments.
Wow. Well, thank you so much, both of you, for being here today and joining us on Building SaaS on AWS. Really have enjoyed this topic. Would love to have you both back on again sometime in the future. So thank you so much for all the great info. And to all of you that are joining us here on Twitch today, hanging out in the chat with Mr. Tar, thank you for joining us as well. Couple of quick housekeeping things. First of all, make sure and join us back here again in 2 weeks. We'll have another great episode of Building SaaS on AWS. And in the meantime, make sure and go out and subscribe to our YouTube channel. On the channel, we have over 50 previous episodes and all sorts of topics related to SaaS. Many of them may be of interest to you, so please take a look at those. If you're interested in learning more about SaaS specifically on AWS, we also have a new landing page on our Building SaaS on AWS website, I should say. Be sure to check that out. And if you happen to be in Indianapolis around March 21st, I will actually be joining one of our SaaS competency partners, Scylla, at an event that they are hosting called SaaS Madness. Now, it is a very limited event, but there may be some spots available if you could reach out to Sela if you're going to be in the area and come by and see me. We have QR codes for all of these links here, and I know Bill put them into the chat. But otherwise, folks, I wish you all a great rest of your week, and we will see you next time on Building SaaS on AWS. Have a good one.